Hello class, in this video I'll be showing you how to find the relative extrema of a function by applying the first derivative test. Let's begin. For example 4, we want to find all relative extrema for the function f of x. But before we can do that, we need to determine the domain. The domain of f of x is all real numbers except 9. And that is because if you substitute 9 into this function, you're going to get some number on top divided by 0. And when you have a number divided by 0, that is an undefined value. So 9 is not in the domain. Now to find the critical numbers. To do this, we need to determine where the derivative is equal to 0 and where the derivative is undefined. So after applying the quotient rule, the derivative is x squared minus 12x plus 72, all divided by the quantity x minus 9 squared. A rational function is equal to 0 when the numerator is equal to 0, and this trinomial factors as the quantity x minus 6 times the quantity x minus 12. So we have x is equal to 6, and x is equal to 12. Since 6 and 12 are in the domain of f, we can conclude that they are critical numbers. Now to determine where the derivative is undefined. The derivative is undefined when x is equal to 9. However, 9 is not in the domain of the function, so 9 is not a critical number. What this means is that the only two critical numbers are x is equal to 6 and x is equal to 12. Now to create the number line. On this number line, I'm going to include both of the critical numbers because this is where the derivative is equal to 0. I'm also going to include the value of x that is not in the domain of f of x. So now there are 4 intervals to test. The first interval is less than 6. The second interval is between 6 and 9. The third interval is between 9 and 12. And the fourth interval is greater than 12. I'll start by testing the interval that's less than 6. So if x is equal to 5, the derivative when x is equal to 5 is approximately 0.4, which is greater than 0. So the derivative is positive when x is less than 6. Next, I'll test the interval between 6 and 9. I'm going to let x equal 8. The derivative at 8 is equal to negative 8, which is less than 0. So the derivative is negative when x is between 6 and 9. Next, I'll test the interval between 9 and 12. So I'm going to choose x is 11. The derivative when x is equal to 11 is approximately negative 1, which is less than 0. So the derivative is negative when x is between 9 and 12. And finally, I'm going to test the interval where x is greater than 12. I'm going to choose 13. So the value of the derivative when x is equal to 13 is approximately 0.4, which is greater than 0. So the derivative is positive when x is greater than 12. So now we are ready to apply the first derivative test to locate the relative extrema. So I will start with the relative maximum. Since x is equal to 6 is a critical number, and the derivative changes from positive to negative at x is equal to 6, there is a relative maximum at x is equal to 6. The value is 0. Now on to the relative minimum. Since x is equal to 12 is a critical number, and the derivative changes from negative to positive at x is equal to 12, there is a relative minimum at x is equal to 12. The value is 12. I'll leave it up to you to graph the function into Decimus and verify the results. And we are done.